Welcome to another lecture on signal and system. This is under Aicte Prerana scheme, MITS Madanapalle. I am Ravi Shankar, Senior Assistant Professor at EC Madanapalle. So in last class we have solved some numerical problems. So today we will continue that. So let us solve this problem related to continuous time LTI system. So question is compute the output yt for a continuous time LTI system whose impulse response st and the input xt are given by ht is equals to e raised to the power minus alpha t into ut and xt is equals to e raised to the power alpha t u minus t for alpha greater than 0. So let us solve this problem. So what is yt? So yt is minus infinity to plus infinity. So we have LTI system. So the input is xt, the output is yt, and the impulse response is st. So yt is nothing but xt convolution with ht. So it is equals to minus infinity to plus infinity x tau h t minus tau d tau. So let us compute this integral. So first we have to see the graph of x tau. So what is graph of x tau? So so x tau is this is your x tau graph. At tau equals to 0, the value is 1, and there is no value in right hand side. The graph exists only in the left hand side. See, this is your x tau. So basically x tau is e raised to the power alpha tau u minus tau. And why it is happening that why this graph is coming? Because that u minus tau, if you plot the graph of u minus tau, then this is graph of u minus tau. It is derived from u tau. So the graph of u tau is like this. For tau greater than 0 it is 1, and for tau less than 0 it is 0. So u minus tau is just, if we time reverse that, so time reversal will produce u minus tau. So this is x tau graph. Now we have s tau graph also. So this is our s tau graph. So at t equals tau equals to 0, the value is 1, and for all other values, for positive values it is just decreasing exponential, and for negative values it is 0 only. So s tau is e raised to the power minus alpha tau u tau. So what is h minus tau? So h minus tau is just time reversal of h tau. So at tau equals to 0 the value is 1, and for all negative values this is just the mirror image. You see, if we can see that so the time reversal, so the time reversal of h tau will give h minus tau. Then we can plot ht minus tau. So ht minus tau, we consider both cases. First case we consider when t greater than 0, second case we consider when t less than 0. So ht minus tau graph is, this is when we consider t greater than 0, when the shift is greater than 0, so this is our ht minus tau graph. And when this t is less than 0, then this is our ht minus tau graph. So this is tau equals to 0, here tau equals to t, here tau equals to 0, and here tau equals to t. So this is ht minus tau when tau is less than 0. So I am going to summarize all the graphs. So we have, first we have x tau, this is x tau, then we have ht minus tau, so this is ht minus tau, when t greater than 0, and this is h t minus tau when t less than 0. So this is figure 1, all the graphs related to figure 1. So let us analyze this problem. So first consider t greater than 0. So when we consider t greater than 0, so we see that x tau, if we see the graph of x tau, if we if we just analyze the graph of x tau and ht minus tau graph, so for t greater than 0, x tau and ht minus tau graphs overlap with each other, and we can calculate yt as, what is the overlapping region? So the overlapping region, if we analyze that overlapping region, then it is overlapping from minus infinity to 0 only. So from minus infinity to, so because this is our x tau graph, this is our x tau graph, and this is ht minus tau graph. So if we see these two graphs, then these two graphs are overlapping from minus infinity to 0 only, otherwise it is not overlapping. Otherwise these graphs are not overlapping. So we have from minus infinity to 0, what is x tau? So x tau is e raised to the power alpha tau u minus tau multiplied by ht minus tau. What is ht minus tau? E raised to the power minus alpha t minus tau u t minus tau d tau. So this is our yt. Now if we analyze this u minus tau, so u minus tau, if we see the u minus tau graph, so it is u minus tau graph. So from minus infinity to minus 0, the value of u tau is 1. From minus infinity to less than 0, the value is 1. Other values it is 0. For tau greater than 0, it is 0. This is u minus tau value. This is u minus tau graph. This is u minus tau graph, and mathematically you can represent like this. Also we can see that ut minus tau. So what is graph of ut minus tau? Because t is greater than 0, so this is u minus t tau graph. Now positive shift will get this is u, because we are providing positive shift, so this is ut minus tau graph. So ut minus tau is equals to 1 when tau is less than t. So when tau is less than t, it is 1. Otherwise for tau greater than t, it is equals to 0. So these 2 points we have to remember. So now using this u minus t and ut minus tau value in this integral, so let this integral, the equation number 1. So using u minus tau and ut minus tau values in expression 1, we get, so what we get yt is equals to minus infinity to 0 e raised to the power alpha tau into 1, because u minus t is equals to 1. Then we have e raised to the power minus alpha t minus tau multiplied by 1, because for tau less than t, ut minus tau is 1. So less than t means minus infinity to 0, the ut minus tau will be equals to 1 only, d tau. So we can further solve this integral. So we can put e raised to the power minus alpha t outside the integral, because the axis is tau axis. So we have 2 alpha tau d tau. Now finally if we solve this, we will get 1 divided by 2 alpha e raised to the power minus alpha t. So what is yt? Yt is 1 divided by 2 alpha e raised to the power minus alpha t. This is our yt when t greater than 0. When t greater than 0. This is our first condition. Now for t less than 0, what is happening? So for t less than 0, so the graph is, this is our x tau graph. This is our x tau graph, and this is our ht minus tau graph. So this is our ht minus tau graph when t less than 0. So now if we analyze this graph, then the overlapping is if there is t point here. So the overlapping region is basically, we have this is our overlapping region. This is our overlapping region. So from that overlapping, so the overlapping region, so it is from tau equals to minus infinity to tau equals to t. From tau equals to minus infinity to tau equals to t, this is our overlapping region. So yt is written as minus infinity to t e raised to the power alpha tau, and from minus infinity to t we have u minus t is equals to 1, and then e raised to the power minus alpha t minus tau, and from minus infinity to t u t minus tau is also equals to 1 into d tau. So further we can solve this. We will get e raised to the power minus alpha t 0 to t from minus infinity to t e raised to the power 2 alpha tau d tau. So solution of this is 1 divided by 2 alpha e raised to the power alpha t. This is our solution for t less than 0. Now we can write in this form. We can write yt. So yt is basically yt is equals to 1 divided by 2 alpha e raised to the power alpha t when we have t less than 0, and it is equals to 1 divided by 2 alpha e raised to the power minus alpha t when t greater than 0. So we have the graph of yt. So it is 1 divided by 2 alpha. It is decaying exponential in positive side, and it is increasing exponential in negative side. And at t equals to 0, we have 1 divided by 2 alpha. So we can write it in this composite form, in modulus form. So it is 1 divided by 2 alpha e raised to the power minus alpha modulus t. And what is alpha? Alpha is greater than 0. So in this way we can write yt. So this is our yt. So this modulus, if t greater than 0, it is alpha t minus alpha t, and for t less than 0, it is plus alpha t. So we can solve another question. So the question is, evaluate yt is equals to xt convolution with ht when xt and ht are shown in figure 1. So xt is given as, this is xt. So from 0 to 3 the value is 1. This is xt, and ht is from 0 to 2 the value is 1 only. This is ht. So this is figure 1. Now let us solve this problem. So the solution of this problem. So we first express st and st in unit step form, because we can represent xt and st in terms of unit step function. So we first represent xt and ht in functional form. So what is xt exactly? Xt is nothing but ut minus 3. So let us explain this. So we have a unit step function ut. So this is ut. Now if we run another unit step function at t equals to 3, but here we have negative sign, so it will go downwards. So you have ut minus 3. Now if we subtract, basically we can subtract from ut this ut minus 3. So what we will get? So this area will cancel out, this area will cancel out, this area will cancel out. So what we will get finally? We will get from 0 to 3. From 0 to 3 we have 1, and from 3 to infinity we have 0. So we will get this box. So it is ut minus 3 graph. Likewise here also, here in for unit for impulse function, we can write in terms of unit step as ut minus 2. So we have ut, and at t equals to t we have another unit step function. So this area will cancel out. So finally we will get from 0 to t to ht. So 0 to 2 ht, and the value amplitude is 1. From 0 to 2 the ht amplitude is 1, and all other values it is equals to 0. So this box we will get. So we can solve this question. So what is yt? Yt is basically convolution of xt with convolution with ht. So it is from minus infinity to plus infinity, x tau ht minus tau d tau. So we can write it as minus infinity to plus infinity. We can put the value of x tau. What is x tau? It is u tau minus 3 multiplied by ht minus tau. So what is ht minus tau? It is u tau t minus tau. It is u t minus tau minus u t minus tau minus, so what is ht? Minus 2, then d tau. So we can we can multiply it term by term, and we can write it in this integral form. We can separate these integrals. So we have minus infinity to plus infinity u tau u tau minus 2 d tau, then minus infinity to plus infinity u minus infinity to plus infinity is the, so multiply this u tau with ut minus tau d tau, then u tau minus multiplied by u t minus 2 minus tau. So u tau u t minus tau minus 2 d tau. Then we have another integral. There are 4 integrals basically. So these two are first integral, second integral, then this is our third integral, that is from minus infinity to plus infinity u tau minus 3 multiplied by u t minus tau d tau. Then fourth integral is from minus infinity to plus infinity. We have u t minus u tau minus 3 u t minus tau minus 2 d tau. So this is our yt. This is our yt. Now we can solve the integral by considering some facts that u tau, if we consider u tau multiplied by u t minus 2 minus tau, so what is that? If we see that it is equals to 1. So when it is equals to 1, it is equals to 1 when we have 0 is less than tau less than t minus 2, and t greater than 2. So it is equals to 1 when the tau value is from 0 to t minus 2 and t is greater than 2, and it is equals to 0 otherwise. It is equals to 0 otherwise. Now we have u tau minus 3. We have this product u tau minus 3, u tau minus 2. So it is equals to 1 for what is the range of tau? So the range of tau is 3 is less than tau, less than t, and t is greater than 3, and it is equals to 0 otherwise. So there is another product that is u tau minus 3 multiplied by u t minus 2 minus tau. So it is equals to 1 when 3 is less than tau is less than t minus 2, and it is equals to 0 otherwise. And also we have t greater than 5. Second is also, that second range is also there. So these are some assumptions that we can apply. These are some assumptions that we can apply in the integral. So what we will get? We will get yt is equals to 0 to t d tau multiplied by u t minus 0 to t minus 2 d tau multiplied by u t minus tau minus 3 to t d tau multiplied by u t minus 3 plus 3 to the lower limit is 3, upper limit is t minus 2 d tau multiplied by u t minus 5. So if we solve this integral, then we will get t ut minus t minus 2 ut minus 2 minus t minus 3 ut minus 3 plus t minus 5 ut minus 5. So basically if we plot this graph, if we plot this graph, what we will get? So we will get this plot. Let us draw the plot of yt. So the yt we will get is, so we will get this plot of yt. Let us plot this yt with respect to t. So the plot is, it is starting from 0 and it will go up to 2. Now we will get the flat slope from 2 to 3. From 2 to 3 we will get the flat slope. Then after that from 3 to 5 it is decreasing. Then we will get the flat slope. So this line is basically, this line is nothing but, this is TUT. So TUT is also, we can write it as RT. So RT is basically ramp function. So RT is nothing but T into UT. RT is nothing but T into UT. So this is TUT line. Then we have this line. This line is we have this line at t equals to 2. There is another ramp, and that ramp is nothing but t minus 2 ut minus 2, that is rt minus 2. Then from 3 there is another ramp function. And what is that ramp function? It is t minus 3 ut minus 3, that is r t minus 3. Then at t equals to 5, we have ramp that is t minus 5 ut minus 5, and it is also equals to rt minus 5. So this ramp has slope 1, because this value is 2 only. This value is 2 only. Now at t equals to 2, there is another ramp, and due to this ramp, and that slope of this ramp is basically 1 minus 1, so that we will get the flat slope here. And at t equals to 3, there is another ramp, so this slope will goes to minus 1, and t equals to 5, we have another positive slope. So this negative and positive slope will cancel out, and we will get again, from t equals to 5 we will get the 0 slope. So this is graph of yt. This is graph of yt, and mathematically we can represent yt. We can write yt in mathematical form, that is yt is equals to, so it is 0. When it is 0, it is 0 for t less than 0. Okay, and then it is equals to t, yt is equals to t for 0 is less than or equal to 2, less than equals to 0 is less than or equal to t less than or equal to 2. Then we have yt is equals to 2. Yt is equals to 2 when it is 2, when 2 is less than t less than or equal to 3. Then yt is equals to 5 minus t when 3 is less than t less than or equal to 5. And finally yt is equals to 0 when t is greater than 5. When t is greater than 5. So this is our graph of yt. So this is our graph of yt. This is graph of yt. So this is 0, this is 2, this is 3, and this is 5, and this is 2 only. The amplitude is 2 only. So this is mathematical form we have represent the yt. Let us solve another problem related to continuous time system. So let ht be the rectangular pulse be the rectangular pulse shown in figure 1, and let xt is the input sample train or impulse train and it is shown in figure number 2. It is shown in figure number 2. It is expressed as xt is equals to del t, capital T, and in bracket small t, summation n is equals to minus infinity to plus infinity del t minus nt. Now question is determine and sketch determine and sketch yt is equals to ht convolution with xt for the following values of t, for the following values of t. So what are the values of t? The first part is, that is part A, it is capital T equals to 3. The second part, that is B part, capital T equals to 2, and C is capital T equals to 1.50. So let us solve this problem. So first draw the figure of HT and del TT. So this HT is a rectangular pulse, it is a triangular pulse basically. It is from -1 to 1 and the amplitude is 1. So this is our HT. Then we have the pulse train. This is del T. So it is the pulse train. So this is T0, this is T, this is 2T, this is 3T, this is minus T, this is minus 2T, this is minus 3T. Now we have this, this is figure 1, this is figure 1, and this is figure 2. So we have a LTI system, the input is xt and the output is yt. So this is the LTI system, the input is xt and output is yt, and the impulse response is ht. So yt is written as xt convolution with ht. So yt is written as xt convolution with ht. So it is ht convolution with xt because of commutative property. So basically what is yt? So yt is nothing but ht. Now xt is pulse train, xt is impulse train. So xt is given in our question, that is n equals to -infinity to +infinity del t minus nt. Now we can put this ht inside that summation, and we can write it as summation n is equals to -infinity to +infinity ht convolution with del t minus nt. So we can write it as summation n is equals to -infinity to +infinity ht minus nt. So this is equation number 1. So how this expression comes? So basically when we have xt convolution with del t minus t naught, then the result is xt minus t naught. So better to take x dash t. So this is our property of this is our convolution property. So here you have ht convolution with del t minus nt. So basically we have ht minus nt. So this is equals to yt. Now draw the figure for let us take the first part, that is capital T equals to 3. So the figure is like this. If we take capital T equals to 3, then we have this yt is equals to summation n is equals to -infinity to +infinity h t minus 3. Instead of
capital T we are replacing with 3, so it is ht minus 3n. Now for n equals to 0 it is ht only. Now for n equals to 0 it is ht only, that is from minus 1. So when we have n equals to 0, so we have only ht in remaining in this summation. So when we have n equals to 1, we have ht minus 3. So the signal is shift. So when n equals to 1, we have ht minus 3, and when n equals to 2, it is ht minus 6. And when n equals to minus 1, so when n equals to minus 1, we have ht plus 3. When n is equals to minus 2, we have ht plus 6. So it is for n equals to 0, then n equals to 1. When n equals to 1, we have ht minus 3. So it is shifted at basically we have shifted it at 3 points. So this 0 will shift to 3. So this is 3. So this is 3. This is 3. Okay. Then further, when we have n equals to 2, so this is this 0th position ht will, because this is ht, it will shift it to 6 points. So this 0, this is 0, the 0 is shifted to 6. Then we have 2 to 4, then 5, 6, 7. So it is 5, 6, 7. Likewise here in negative side we have this plot. So it is minus 2, minus 3, minus 4, then this is minus 5, minus 6, minus 7, and so on. So it is like this. So this is yt when you have capital T equals to 3. When you have capital T equals to 3. So this is plot of yt. Now let us do the second part. The second part is we are taking capital T equals to 2. In second part we are taking capital T equals to 2. So for part B, for capital T equals to 2, this equation, that equation yt, so yt will become summation. So yt become summation n equals to minus infinity to plus infinity h t minus 2n. Okay, so let us plot this. Let us plot yt. So this is our yt with respect to t. Now we have this for n equals to 0 we have ht. For n equals to 0 we have ht. So it is 0, it is plus 1, it is minus 1. Then for n equals to 1, it is shifted to 2 points. So 0 is shifted to 2, so, and this 1 is shifted to 3, and this minus 1 will shift to 1. So basically we are getting this type of plot. So we are getting this type of plot when you have capital T is equals to 2. So it is 0, plus 1, minus 1, then it is so this point is 1, then we have 2, then it is 3, then 4, this is 4, this is 5, this is minus 2, this is minus 3, this is minus 4, this is minus 5, and so on. So it is our yt. with respect to t when we have t equals to 2. So this is t equals to 2 condition. Now the third case is when we have in the third case we have for t equals to 1.5, this equation yt is equals to summation n equals to minus infinity to plus infinity ht minus, it will become ht minus 1.50 n. So here we consider that t equals to 1.5, so it is ht minus 1.50 into n. So note that so let us first plot that. Let us do the plot first, then we will analyze the plot. So the plot is like this. We have for n equals to 0, we have 0 plus 1 minus 1. Now for n equals to 1, it will shift to 1.5. So 0 will shift to 1.5, 0 will shift to 1.5, 1 will shift to 2.5, so it is 2.5, but the minus 1 will shift to 0.5. So basically minus 1 is here. So this is our 0.5. So this is our graph. Okay, this is not perfect graph. Okay, so this is our graph. So here also we will get some overlapping, and so on. Likewise here we will get some overlapping. So what is happening that we will get the overlapping. So this is overlapping, basically this is overlapping. Okay, so what is happening that, so note that when t is less than 2, the triangular pulse are no longer separated, and they overlap. So if we summarize all the previous cases, so when we have taken that t equals to 3, then there is no overlap. And triangular pulses are separated. Now in case when we are considering t equals to 2, so when we are considering t equals to 2, so this is the critical condition, we can say. Just it is avoiding the overlap. You can see here it is just avoiding the overlap. So it is critical condition. And when we have taken that t equals to 1.6, here when we have taken 1.5 here, then we are getting the overlapping. So basically these triangular pulses are overlapping. So these triangular pulses are overlapping with each other. Okay, so let us solve another problem. So the problem is, consider a LTI system. Consider a continuous time LTI system described by yt is equals to transformation of xt. And it is equals to, so basically that LTI system is we have xt, this is LTI system, we have xt, then we have yt. So what is yt? So it is impulse response. Yt is nothing but system operator. Inside that we are putting that xt. We are putting that input inside the system operator. So the relation is given in the paper. It is equals to 1 divided by t minus capital T divided by 2 to t plus capital T divided by 2 x tau d tau. So this is our question. Now we need to find out the part A. We need to find out find and sketch the impulse response ht of the system. Second part B is this system causal? Is this system causal? Is this system causal? So we have to solve these two problems. So let us solve this problem. So first is the first part. So what is first part? That yt is given. That is 1 divided by t. It is 1 divided by t. It is t minus capital T by 2 to t plus capital T by 2 x tau d tau. Now because we can separate this integral into two parts by using some mathematical manipulation. So I am writing yt as 1 divided by t minus infinity to t plus capital T by 2. Please check this. It is very simple integration manipulation. Just check it. This minus infinity to t minus 3 by 2 x tau d tau. So just I have this as I have separated this integral. Into two parts. So we can write it as this is equation number 1. So we can apply two properties. So using property 1, using these properties, the first property is xt convolution with u t minus t naught is equals to minus infinity to t minus t naught x tau d tau. So this is our first property. So when we will do convolution of xt with ut minus t naught, it is equals to minus infinity to t minus t naught x tau into d tau. Then as the second property we are going to use is xt convolution with h1t plus h2t is nothing but xt convolution with h1t plus xt convolution with h2t. So we will apply these two properties in one. So applying property 1 and 2 in one in expression 1, in the expression of yt. So what we will get? We will get yt is equals to 1 divided by t xt convolution with u t plus t by 2 minus 1 by t xt convolution with u t minus t by 2. Okay, please check this. We have used these two properties. Now it can be further written as, so it can be further written as xt convolution with 1 divided by t u t plus t by 2 minus u t minus t by 2. So in this way we can write this. Now we have this xt, it is written as xt convolution with ht. So this is yt, and yt is basically equals to xt convolution with ht. So this is yt is equals to xt convolution with ht, hence proof. So thus we obtain, so what is impulse response? So basically what is impulse response? The impulse response ht is nothing but 1 divided by t u t plus t by 2 minus u t minus t by 2. So this is our impulse response. The ht is our impulse response. So basically we had find out the relation that xt, ht and yt. So this is our LTI system. So yt is nothing but xt convolution with ht. So so we have written this expression. Please understand that. So we have written this expression. Okay, please. So we have written this expression yt is equals to xt convolution with ht. So basically this whole expression, so basically this whole expression is ht. This whole expression is ht. This whole expression is ht, that is impulse response. Impulse response. So we find out the impulse response ht is equals to, we find out the impulse response ht is equals to 1 by t. So it is equals to 1 by t when we have minus t by 2 is less than t, less than or equal to t by 2, and it is equals to 0 otherwise. Because what is ht? Let us explain this. We have ht is equal to ut plus t by 2 minus ut minus t by 2. So let us plot this graph. So you have a unit impulse function of that amplitude 1 by t. So it is basically starting from minus t by 2. So and there is another impulse function which is starting at plus t by 2, and basically we will get a box. So this impulse is going like this way, this unit step is going like this way, and there is another impulse that is going like this way. Basically they will cancel out. So finally we will get this box only, that box of amplitude 1 by t. So this is our ht. This is our ht. So the impulse response of the system is, so the impulse response, that is ht, that is impulse response, is from minus t by 2 to plus t by 2. The amplitude is 1 by t. This is our impulse response. Now second part is this system causal? The second part is B, is this system causal? Now if we analyze that impulse response, we can say that because ht is not equals to 0 for t less than 0, the system is non-causal. So from this figure, from ST plot, we see that HT is not equals to 0 for t less than 0. Hence the system is non-causal system. The system is non-causal. It is not causal because some part is lying in the negative side also. The system is non-causal because the HT is not equals to 0 for t less than 0. So let us solve another problem. The problem is, let Yt be the output of a continuous time LTI system. Let Yt be the output of the continuous time LTI system with input xt find the output Yt, find the output Yt of the system, find the output Yt of the system if the input is x dash t. So x dash t is d by dt of xt. So let us solve this problem. So we have considered the LTI system, that is xt is input, then we have LTI system and the output is Yt and the impulse response is st, then Yt is equals to ht convolution with xt or xt convolution with st. So we can use any of the expressions. So better to use this expression. Better to use this expression. So what is Yt? So Yt is nothing but minus infinity to plus infinity h tau xt minus tau d tau. So differentiating equation 1 on both sides, we get with respect to t, so we get y dash t is equals to d by dt minus infinity to plus infinity h tau x t minus tau d tau. So basically if we differentiate it, then we can put the differentiator operator inside that integral. So what we will get? We will get minus infinity to plus infinity it is minus infinity to plus infinity h tau x dash t minus tau d tau. Okay. Then we can write it as y dash t is equals to h tau ht convolution with x dash t by the definition of convolution integral. So what is that? What is the conclusion of this problem? So we have system, we have LTI system, we have LTI system. Then if we are giving input xt, if we are getting output the yt, then if we are applying the input x dash t, then output we are getting is y dash t if we apply the input x dash t. So this is our conclusion. This is our conclusion of this problem. Now let us solve another problem. So verify, the problem is verify the bounded input, bounded output stability condition for continuous time. The question is verify the bounded input, bounded output stability condition for continuous time, LTI system, continuous time LTI system LTI system. Okay, so this is the condition. We have to verify the BIBO stability of the continuous time LTI system. So assume that the input xt of a continuous time LTI system is bounded. So because we have considered that bounded input, bounded output system, we have considered that BIBO system. So it is assuming that we are assuming that the input, that is xt, modulus of xt is less than or equal to k1 for all values of t. So basically we have BIBO system we are considering. So we are basically that considering that bounded input, that input is bounded. So for bounded input we have modulus of xt is less than or equal to k1 for all values of t. This is the condition, and this is condition we are assuming. So what is yt? Yt is nothing but ht convolution with xt, and it is equals to minus infinity to plus infinity h tau xt minus tau d tau. This is our yt. Now if we find out the magnitude of yt, then it is equals to modulus of yt, it is equals to modulus, inside the modulus we have minus infinity to plus infinity h tau xt minus tau d tau. Now it is less than or equal to minus infinity to plus infinity modulus of h tau xt minus tau d tau. Now further it can written as minus infinity to plus infinity modulus of h tau modulus of xt minus tau d tau, and it is because this is bounded input. This is bounded input. So the value of this so basically this value is k1. So we can put outside this k1, and it is equals to minus infinity to plus infinity modulus of h tau d tau. Now since modulus of x t minus tau is less than or equal to k1, it is given in problem. It is given in problem that we have bounded input. We have considered the bounded input. So therefore if the impulse response is absolutely integral, that is minus infinity to plus infinity, modulus of h tau d tau is equals to k less than infinity. Okay, then modulus of yt is less than equal to k1 into k, and it is equals to k2, and it is less than infinity, and the system is VIBO stable, and system is VIBO stable. So in short, if your input is stable, then if your impulse response is absolutely integral, this is the property of LTI system, then your output will also be stable. So this is called bounded input, bounded output stability condition of the LTI system.